All right. Our second set of examples, 4 and 5 here, have radicals that have not been simplified. So sometimes we are going to have to simplify them first. So we're going to try to reduce the inside number and make the outside number bigger. So I'm going to do this piece by piece. So I'm going to do 6 root 245. And then we will work with 3 root 125. And then lastly, we'll look at root 80. So looking at the 6 root 245, use my calculator, I can do y equals 245 divided by x and look at my table. When I look at that table, what I notice that stands out when we have 5, that means the other number is going to be 49. And 49 is one of those perfect squares that breaks down to 7 and 7. So we take that 7 outside with the 6 that is already outside, and our 5 is going to stay inside. So we have 6 times 7, root 5. 6 times 7 is 42, root 5. So that is 1 down, 2 to go. Looking at root 125, I know that this is divisible by 25. So that would be 5 and 25. Again, you can use your calculator. And 5 is going to break down to 5 and 5. So again, we have a pair of 5s. I have a 3 outside. So those are going to go outside. And then I also have this 5 that's going to go on the inside. I'm starting to notice a pattern. That 5 is on the inside. You will have problems where you're going to have different insides, but you might also have problems where they all have the same inside. So you might be able to kind of shortcut some of your answers, and I'll show you how to do that with 80. So we have 3 times 5, which is 15 root 5. So I have a hunch that this is also going to have a root 5 left over, which means it's divisible by 5. So 80 divided by 5, if you're calculating, you can find that that's 16. And 16 is also a perfect square of 4. So 4 is going to go outside, while 5 is on the inside. So 4 root 5. For our final answer, I am just going to add those outside numbers together, 42 plus 15 plus 4, and that's going to give me 61 root 5 as my final answer for example 4. So if you ever need to pause, if I'm talking too slow, pause, copy it down, come back to it. Looking at example 5, we're going to do the same process. I have 6 root 27 plus 8 root 12 plus 2 root 75. 27, I know, is divisible by 3 and 9 gives us that perfect square root. So I'm going to circle the 3. It's going to go outside with the 6. 6 times 3. And we have that singular 3 left over. That's going to go back inside. 6 times 3 gives us 18, and then root 3. Then we have 8 root 12, and you can pick whichever two numbers. You can do 2 and 6, or you can do 4 and 3. I like 4 and 3. Since my first radical had a simplified version with 3 on the inside, I'm going to keep with that 3 on the inside idea. 4 breaks down to 2 and 2, so that pair of 2's goes outside with the 8. 8 times 3, and we have that leftover 3 that'll go inside. 8 times 3 is 24, and then root 3. Lastly, we have this 75. 75 is divisible by 3, and that gives us 25. So we have 5 going outside with this 2, and a 3 staying inside. So we have 2 times 5, root 3. 2 times 5 is 10, root 3. And if we add these together, 18 plus 10 plus 24, we get 52 root 3.